Welcome to the Revolution Against Evolution. I'm your host, Rich Geer. My main host is behind the camera today because he wanted me to talk to the dinosaur guy here. Marcus Ross, who's taught at Liberty University, 16 years?
16 years, yeah.
That's amazing. But now he and his wife are doing a new venture. You want to tell us a little bit about that?
Sure. After teaching college classes and university courses and creation issues, one of the passions that we developed for my wife and I was to start bringing creation-related science materials to homeschool, private school, college, and universities. So we started a Cornerstone Educational Supply to be an all-purpose science supply shop. So if you need biology or chemistry, physics, earth science, it's all there.
Wow.
And our geology kits, for example, have a creation-based geologic timescale in them, so that when people open that box of rocks and they're trying to figure out, well, what, usually you open up a box and it comes from another company and you're not sure, what if this is real? What if it, can I say it's talking about millions of years? What do we do? And our geology kits actually will have a time scale that will show the old Earth ages on one side and a young Earth interpretation of the geological record on the other, to help them translate. So the next time they go to a museum, the next time they're watching a special on TV and they're talking about when these things happened, they can look at that and say, oh, wait, this is how it actually fits into a true biblical history.
Yeah, we've seen some things like that over the years, and that would be very handy. In fact, I wouldn't mind having something like that myself, a little chart like that. Because you look at things of like Precambrian and through Cambrian and Ordovician and Silurian and all those. I mean, when I was in first grade, I knew every era and epoch and eon of the geologic time thing more than the Catholic nuns. I went to a Catholic school first, second grade, and I got in trouble because I lipped off to a nun, and now all the things I lipped off to her about, I find are wrong. So.
But you still got your knuckles wrapped for it.
But I still did. Oh boy.
Yeah,
well, I tell people I was raised on peanut butter and Ritalin, so the fact of the matter, I was too hyper for my own good. And in a Catholic school back in those days, that was not a recipe for good things. But they put up with me despite that. But anyway, your specialty, that's the geological part of it, which I love, because you talked to me early before the start of the show about flood, post-flood boundaries, things like that.
Yeah. But
your real main interest is the dinosaur era, if you will, and specifically the seagoing, the mosasaurs. Yeah. And there was a question I asked you earlier, and you said there is an answer, because I wanted to know this for a long time. Is there a difference between a mosasaurus and a tylasaurus? Because the genera is mosasaurs, right? Isn't that what it is, or am I wrong?
So the family is usually referred to as the Mosasauridae.
Yeah,
right?
okay.
So idae is always the way that biologists put families names on,
okay.
and then we usually have like us at the end for a genus or something.
Right.
So Mosasaurus is actually a genus, and within that genus there are several different Mosasaurus species as well.
Okay.
So for example, the highest Mosasaurus species that we have is Mosasaurus hoffmanni, which is known from the Netherlands and Belgium, and also on the east coast of the United States and down in the Gulf. So it's a pretty widespread mosasaur species. So Mosasaurus is a genus with a couple of species, and Tylosaurus is a different genus that also has a few different species in it, and they're all within the larger family of the Mosasauridae.
So what are some of the differences between them that you could recognize, like some layman maybe?
Right. Now, if one was coming at you, wouldn't care what the differences between the species are, because you'd be dead.
That's correct.
Praise the Lord, they are all off the face of the planet at this point, because they're all big, toothy, big swimming marine reptiles that are just dangerous.
Yes.
And if you saw Jurassic World,
Love Jurassic World.
That was a good one. I know. And I've been waiting for the mosasaurs to show up. I'd heard rumors for a decade and a half that they were showing up, and not in Jurassic Park 2, not in Jurassic Park 3. Finally made it, and did they steal the scene? I mean, it was
very cool. But I've always been looking for the ankylosaurus,
Oh yeah,
because they never showed those either. So
and that was
that was awesome.
A great scene. So the mosasaurs, we've got actually about 40 different genera of mosasaurs in the fossil record. Many of them, the smallest of them are about 10 or 12 feet long.
Is that what makes sometimes they consider them different, because of the size of them?
It's more than just size, actually.
It had to be more than size, but I'm just curious,
So my PhD dissertation was actually on the mosasaurs as a family, and so I had to get really familiar with the biology and with the anatomy that helps us distinguish between one and the other. So
let me stop you there.
Yeah.
How are you getting familiar with anatomy when basically all you have is bones?
Well, there's a lot about anatomy that you can learn from the bones.
Okay.
Because if we think about our own bones, right, we've got our muscles on top of them and skin on top of that. But if we get down to the bone, that's where the muscle grabs hold of. That's where the tendons and the muscles get to hold on. So we can actually look at a bone from a dinosaur or a mosasaur or another extinct animal, a smilodon, the saber-toothed tiger,
yep.
and we can look for places where there are muscle scars on the bone. Not only does it tell us where the muscle goes, the size of the scar can actually tell us the approximate size of the muscle. So we get an idea as to whether or not Smilodon, for example, had really large forearms, which it did. It was comparatively bulkier than, say, an African lion. So we get a sense for not only where the muscles go, but also a little bit about how big they might be. And sometimes we get skin impressions or scales or other sorts of things.
I wonder with some of the rapid burial in the Noah's flood, whether you actually got some skin impressions of Mosasaurus. I didn't know if we.
Yeah, we do, and in fact, their scale system looks very similar to varanid lizards, like a Komodo dragon, and like snakes. In fact, like snakes, the mosasaur skin that we have has keeled scales. So they actually have like a little ridge over the top that helps water flow over them and be really smooth as they go.
How cool is that?
So if you go back and watch that, a couple of those scenes from Jurassic World, you'll see on their scales that there's keels on them.
Well,
so
they
did right. Yeah,
CGI,
now they made
CGI is incredible.
Now they made them a little bit too big.
Yeah, I wondered about that.
About 3.
Yeah, that was huge.
But
well, I was thinking they were doing a Chronosaurus or something at first,
And even that, actually, funny thing, we think of the Chronosaurus as being so gigantic. The largest mosasaurs were actually bigger than Chronosaurus.
Really? That thing was like 50 feet long, wasn't it? 60 feet, 50 feet?
Yeah, if you watched Walking with Dinosaurs, they inflated its size a little too much. And the actual Chronosaurus, about 30, 35, 40 feet, which is huge. Yes. And the biggest mosasaurs, such as Mosasaurus hoffmanni that I mentioned, that one, the biggest skeleton we have is 54 feet long. Okay. That is 10 feet longer than the biggest T-Rex.
Yeah.
So
I know. Well,
these things are huge.
Water creatures seem to get bigger.
When you're in the water, there's all kinds of advantages, right?
Buoyancy.
You don't have to worry about fighting gravity nearly so much. It also means that mosasaurs are not going to be able to hoist themselves up on land to lay eggs like sea turtles do.
Right.
Sea turtles have all this armor and they're comparatively small. Mosasaurs, we actually know from the fossil record, must have given birth to their young live out in the open ocean.
Wow.
That's because we found the remains of neonatal mosasaurs in the pelvic cavity of rabid females.
That's kind of like the ichthyosaurus.
Yeah.
Didn't they lay their young live?
That's right. Yeah, they did a live birth. In fact, almost all of the marine reptiles that we have in the fossil record, the plesiosaurs, the ichthyosaurs, the mosasaurs, other things called nothosaurs and placoderms, everything so far, except for probably crocodiles and turtles, had their kids out in the ocean.
They birthed them live.
Birthed them live, yeah. So
wow, that's something.
There's a couple of different ways in biology, even in modern reptiles. There's a bunch of snakes and lizards that will give live birth, and what often happens is instead of when the egg is fertilized, usually we think, okay, then there's a shell that gets built over and it passes out and is put in a nest.
Yeah. Especially with reptilian creatures. Yeah.
That's right. In this case, and in some of the other snakes that have live birth, like garter snakes do, for example, the egg shell will actually dissolve inside the body cavity.
Okay.
And the embryo will just hunker down and stay in there. And it will be passed out when it's mature enough to start going. So mosasaurs not only gave birth to their young live, but they gave birth to them, well, I can't say alive and kicking, they had flippers, but alive and flipping.
Alive and flipping. I like it. That's pretty good. Now, back a little bit, so what are the Tylosaurus and the Mosasaur, what are some significant differences between them?
Sure. So if we think about a basic reptilian head, between the upper skull and the jaw, it's kind of a simple hinge.
Yep.
We've got one bone that starts in the middle. It's fused here. It's the dentary. Yep. We call the whole thing the mandible. And this goes up and over here. So mammals do that sort of thing. They tend to have one big dentary bone. Reptiles, birds, amphibians actually have that dentary bone out front, and then they have a bunch of other little bones that come out, and their hinge is way in the back, behind the dentary.
Snakes, so they could open up their jaw real wide.
That's right. And mosasaurs, like snakes, had kinetic capability in their jaws. So at the end of that jaw is a ball-shaped bone, or kind of a sometimes question mark-shaped bone or oval-shaped bone. It's called the quadrate, and that's the hinge between the upper and the lower jaw.
All right.
So you got the lower jaw, the quadrate, the upper jaw. that quadrate, it turns out, is one of the most diagnostic bones that if I wanted to know what mosasaur I was looking at, that's the one bone I'd ask for. If you could only give me one. And the reason for that is because if you think about the parts of our body that are very, very active, say for us, our fingers, our jaws, toes, things like that, that are always moving and always doing something, they're very highly specific. They have to do very particular types of jobs. For the mosasaurs, it seems that each genus, at the very least, has a very specific setup to its quadrate bone.
Oh, is that right? Okay.
Because it's an active point where there's lots of movement. And depending on what sorts of food they're going after, how large their jaws are, what sort of muscle mass they have, seems to be playing in a little bit on the shape of that quadrate bone. So sometimes it's kind of like a ball with a little stick coming out of it. Other times it's a question mark. Sometimes it's almost a completely closed circle. Sometimes it's a closed circle. So those are some of the things that a vertebrate paleontologist studying mosasaurs would be looking for to diagnose which ones they're looking at.
So a layman, if they looked at a tylosaurus and a mosasaurus, they probably couldn't tell the difference between them?
It would be hard.
That's what I was asking.
One of
Okay.
the easiest places to see the difference between tylosaurs, because it's really unusual compared to other mosasaurs, is at the very end of its snout. If you look at where the last two sets of teeth come out, there's
Yeah.
4 teeth in a bone called the premaxilla.
Okay.
So the maxilla
I
in us is all
Yeah.
this bone, and then they have an extra bone in the middle, and it's got 4 teeth on it. The Tylosaurus has got an extension. It's like a big schnoz, if you will. We call it a rostrum, which basically means nose, but it's not really the nose. It's just a projection of bone that extends out from those teeth. And so they've got this kind of ramrod coming off of this premaxilla bone. Mosasaurs, most of the other mosasaurs, and Mosasaurus in particular, that premaxilla ends right in front of the other teeth.
Other teeth, okay.
So if somebody handed me a premaxilla, that's another very diagnostic bone for various mosasaur genera and species. But if I picked up one and it had this big rostrum out in front of me, this is a Tylosaurus or maybe Hanosaurus, but that one's usually in Europe. So probably looking for Tylosaurus.
So is that a Tylosaurus type of?
Yeah, it would be a really close cousin to Tylosaurus.
Okay.
So we there's enough anatomical difference that we recognize them as different genera and species.
So,
but pretty close to the
so
same.
you could, by knowing that you could maybe tell the difference.
Absolutely. If you were walking into say the Smithsonian Museum and you saw Tylosaurus, you'd see that big schnoz. And if you walked around the corner and saw Clydastes, it's another mosasaur. It's right next to it there.
Yeah, I've seen that.
You can see both of them and go, oh yeah, I can see some of the different ways that the skull is constructed. If you look at the paddles and the flippers, you can see the way the finger bones are different.
They are different, okay.
Oh yeah, the finger and especially the wrist and the arm bones will look different in the scapula. And so hands, feet, flippers, again, all those active components that have a lot of mechanical use, always going to be the diagnostic things.
Okay.
You hand me a rib,
Yeah, okay, yeah.
it's a rib.
Well, I've
That's
looked
all I
at
can
too,
tell you.
even the dinosaur. I look at a lot of these. You go from, they got three fingers on the forearm or 2.
Yep.
That gives me some. But some of them, I go, what's the difference between this one and this one? And I had a big fun thing with young people. I was trying to tell them the difference between a dinosaur, and I would point up like a Mosasaurus. Is this a dinosaur? And they go, yeah. No, it's not.
Yeah.
And a lot of people don't know that because we're so brainwashed into a certain age of reptiles that everything that's prehistoric. And of course, as a creationist, we don't believe that. Everything's historical, and it's in the time that men would have been around, and that's why we have all these legends of sea monsters and land dragons and everything else. But I said, as I pointed out, a pteranodon, the flying ones. How about this one? They were a little more. They weren't sure if they were going to get caught. So somebody gets. Nope, not dinosaur.
That's
then
right.
Then I'd show them a T-Rex, and they go, oh yeah, you're right, that one is.
That's right.
Then I show them a Dimetrodon,
Yep.
Dimetrodon, and they go,
big sail.
Yeah. Nope, not a dinosaur.
Yep.
And we need to tell you the difference between dinosaurs and non-dinosaurs for people to understand what the difference is.
Yeah. So again, in paleontology, we deal with the science of what's called taxonomy. In biology, that's how to figure out what categories things go in, from genus and species all the way up to kingdoms and phyla and those sorts of things. So dinosaurs are part of a larger group that we call the Archosaurs. A modern Archosaur today, for example, are crocodiles and alligators.
Right.
Their name means ruling reptile. I like that.
Yeah.
Right?
Arc.
And so let's think of a crocodile for a minute, and let's think of a lizard. Lizards are part of a different group of reptiles that we call lepidosaurs. So the lizard group is technically called lepidosaurs. And when we compare the anatomy of alligators and crocs to lizards, we find that there's actually a lot of differences. A Komodo dragon is a different sort of critter than a crocodile or alligator is.
Okay.
One way that there's difference is take a look at the tail. Right? When you see a croc walking that high walk,
Yeah.
and you see that its tail kind of goes out for a little bit and then
Yeah.
starts to droop,
Yeah.
does that remind you of a lizard? No, because lizard tails tend to just droop all the
Yeah.
time. They go flat on
I
the
never
ground.
thought of that. Yeah.
And that's because archosaurs, and dinosaurs fall into this category, so that's where we're going with this, is that archosaurs have an expansion on their spinal column, each one of their vertebrae around the tail,
Okay.
that comes up high and flares out a little bit. This allows tendons to wrap around that, and it stiffens and holds the tail up.
Okay.
So for the crocodiles, that extension only holds the tail up so far before it begins to droop. But with dinosaurs, it extends far enough that the dinosaurs could hold their tail completely out.
So I agree with you. So crocodile, even though they're part of the Archosaurs, they're not a dinosaur.
That's right.
Okay.
That's right. It's kind of like saying, hey, you and I are mammals, but we're not mice. Right? Mice are very different.
Yeah.
I mean, of mice and men and
Yeah,
all.
mice
but,
and yeah.
but mice are different from us, but we're both mammals because we've got hair and there's the three
Birth,
bones
live,
in the
young,
ear, birth, live, young. That's right, milk production in females.
Yep.
So those are the categories that all creationists have recognized, going back to Carl Linnaeus as far as
Linnaeus.
defining.
Well, he was a creationist.
Oh, yes.
I don't know whether he was what we would call him in a modern day with some of the things but he was, as far as I understand, and he looked at the different kinds, and of course he put the word species in there. We had a lot of trouble back in the 1800s by talking about fixity of species.
Yes.
We had a lot of trouble, and I tell people on our show, Doug and I have done this a lot of times. Even though there's overlap, there's interface. Don't equate necessary secular words or scientific jargon with the same thing as biblical words, because they're not exactly the same. A kind and a species are not the same, or even a genera or a family, they're just not the same. Or I used to do this in something like there was no death before Adam, and then somebody said, "Yeah, well, you ate plants, didn't you?" I said, "Well, plants are not biologically, or they're biologically alive, but they're not biblically alive."
Right.
And that's a difference. And I go, and yet we have to think that as creationists. I imagine you've run into this with the stuff you go into. We have to be very careful our definitions, because we're not the dominant paradigm. And that's a real problem.
True. We have to recognize the terms that are being used around us and the way that they're being used.
Yep.
And sometimes that means we enter into a conversation and say, okay, well, these are the ground rules, and this is the way that we have to do it. When I was working on my PhD, it was from an evolutionary old age standpoint, because I was at a school that affirmed old age and evolution, and they were not going to allow me to do a creationist thesis.
Okay.
And to a degree, I didn't want to do one either, because I wanted to be able to show people that I was competent in paleontology in the way that paleontologists judge competence.
Yeah.
So even though I disagreed with some of the way that my dissertation gets written out, my approach was, if we're working within this particular worldview, then this is how we should understand the data. And I can step out of that worldview and enter a different one, a creationist perspective, and say, well, the data are still the same. Right? They're still the same mosasaurs. They're found in the same rock layers in the same places. There might be another way to understand them besides the evolutionary perspective. So getting back to Linnaeus here for just a second, then we'll pull in those dinosaurs again. So Linnaeus was absolutely a creationist, and the reason that he used the word species is because that is the word in Latin for kind.
Really? Okay.
So Linnaeus, being a good, educated man of his time, wrote in Latin. In fact, his Systema Naturae was all in Latin.
Okay.
So he chose the word species because in the Latin Vulgate, that is the translation of min, the Hebrew word kind. So kind is species in Latin. But then when it came to biology, Linnaeus was trying to say, we can discover what the created kinds were.
Oh.
And so he called them species, as opposed to genera, which he meant were the general groups.
Okay.
Now, early on, Linnaeus thought that there was a fixity of those species because he believed in fixity of kinds.
Yeah, okay.
Later in the editions, as he started to discover that there was evidence of interbreeding and hybridization amongst different species, he backed away from the idea of species fixity. So you're right, we got into a lot of trouble in the 1800s on this idea of species fixity, but even Linnaeus didn't agree with species fixity by the time he died.
See, but a lot of other ones glommed onto some of that stuff, and the problem is words change over time.
Yeah.
And that's the real problem. I tell people, look at you, if you say, I'm just trying to think, we said let somebody do something, It literally meant prevent in the biblical Greek.
Mm.
It means prevent. But that which prevents shall prevent, if you know the scripture I'm talking
Yes.
about. But anyway, the point of it is that words like charity meant love. It was agape, but it's like, no, now it means giving money to somebody, to the poor, you know. And there are things like that I've watched over the, when they say, wherefore art thou Romeo, it means, why are you a Comey? Not like, where are you?
Right.
I mean, the words change, and I
Yeah.
see that with the species kind business, because now they're making a big thing about that. I did not realize, I guess I didn't look into it that much, but they use the species, and they try to get people to really understand, you know, because fixity of kinds pretty much is fixed. I mean, kind as we understand it biblically is fixed. A mammal always stays a mammal.
Right.
It never comes from a reptile. So there are limits. There are genetic and real lines of demarcation between these different kinds as we mean it. But species, on the other hand, that's a lot more fluid.
So you're absolutely right. You know, the way that the term ends up getting adopted in different ways has led to some of this confusion.
That's what I'm saying, yeah.
So, you know, for the folks that are listening on, yeah, we don't believe in fixity of species in the way that we think of biological species.
Right.
The kinds are going to include a variety of them. You know, how many kinds of mosasaurs were there? You know, there's probably, my own studies indicated that there were probably at least 3 kinds, probably at a subfamily level.
Okay.
And within those, the genera inside that were probably all part of one kind each. Now, I could be right, or I could be wrong on that, right? That's part of the fun of science, is that the more we discover about the world, the more we can go back and see how well our ideas have done.
Well, that holds up. Not that one, not so much.
That's right.
Yeah,
And, you know,
that's what they call the self-correcting part of the scientific. And I like that. That's why it's an art. It's a science, but it's an art to try to come up with. That's why I had to ask you the question about how you figured out, biological things from just bones. You know,
Right.
and how you could figure out anatomy and anatomical things. And
There's all kinds of fun
you know?
things like figuring out where the nerves of the brain go. There's actually little exit points on the bones of the skull,
Wow.
and we call those, you know, what goes through those are what are called the cranial nerves. And so if you look at a very well done diagram of a mosasaur skull that somebody's doing for a formal treatise on it, they're going to be noting with little, you know, X, you know, that's cranial nerve 10 over here, and they're going to have special little terms
very interesting.
for the different bones, because every one of the bones in a reptile skull has got a different name, just like our bones have different names. They just happen to have more bones than we do.
Yeah.
Now,
Go
we
ahead.
were talking about dinosaurs and archosaurs. So
Yeah.
dinosaurs are archosaurs because we can see things like that expanded neural spine that helps hold up those
Okay.
tendons. We can also see a couple other features that they have. And once we realize that, we say, okay, crocodiles, dinosaurs, pterosaurs are also archosaurs. So, okay, looking at all of those, then how do we distinguish between the crocs and the pterosaurs and the dinosaurs? And then we start looking at something like
Now, are the
posture.
mosasaurs an archosaur?
No, they're actually on the lizard side of things.
They're on the lizard side.
So they're
of
going to
things.
be in that group that I called the lepidosaurs.
Okay.
They're probably most similar to snakes or varanid lizards, or, you know, they're anatomically like
Right.
these
Are there
guys.
any sea-going one that would be in the Archosaur category, like
Oh, yes. There are a large number
maybe
of...
the Archelon?
No, that would be one of
That's
the
turtle.
turtles. Yeah,
Turtles,
the turtles
yeah.
are kind of like in their own...
Their own thing. Yeah. Okay. So now we have another one. Okay.
Turtles are weird.
Okay.
And I love turtle. I mean, turtles are great. From a creation standpoint, turtles are really fun.
Yeah.
So you got turtles on one hand, you've got crocodilians, and there are a number of marine crocodiles in the fossil record. Probably at least a dozen families of marine crocodiles.
Wow.
There are 52 families of crocodilians in the fossil record. 52. It's crazy. There's all sorts of, even a herbivorous one, which is
What?
Yeah.
Really? Wow.
Little squat crocodilian sort of thing with
Maybe he's a leftover
blunt
from
teeth.
before the fall.
Yeah. And
Whenever it was vegetarians, you know.
and his shovel is kind of his snout is kind of shovel shaped, so it seems like he was actually like digging around looking for roots and things
okay.
like that. And very well armored and porky. So you know, because
What's he called?
good.
I had to ask you that.
Yeah, I can't
I do
remember
this
it
to
off-
Doug all the time, you know. So don't feel
I
bad.
can't remember that one offhand. A couple of my colleagues who'd watch this are like, "Come on, Marcus, you should
You should know this.
I do, guys. I taught it in paleo. It was a couple of years ago. Sorry. So dinosaurs, on the other hand, have a couple of features that the crocodilians don't have. All of them have teeth that are set in sockets, so that the teeth come straight down out of a hole in it. But dinosaurs, for example, are upright walkers.
That's the one thing I would say. They do not walk like mammals.
Yeah.
And but they're reptiles. This is what was fascinating to me.
That's right.
That's why the crocodiles, their hip girdle is more like out, because isn't it the ornithischia and what there's there's two different
Saurischians and the ornithischians.
Ornithischian, yeah.
So yeah, those are the two big divisions of the dinosaurs. Traditionally, there's some question about whether that works quite right these days, which is interesting.
Always.
But well, yeah, new stuff, and then you're I don't know if we know what we think we know. But when the dinosaurs, we've got the upright stance. We have an expansion on the humerus bone that flares out and allows for a big muscle out over here that we call the deltopectoral muscle.
Okay.
Like this one and this one, our deltoid and our pectoral. For them, they've got this big crest up here that anchors that arm into there. And they also have a bit on their femur, their leg bone, that sticks out, and it's an anchor point for a tail muscle. So the tail is connected actually to the legs, and that's one of the ways that dinosaur tails, why they would sway back and forth, is because every time they took a step, it would kind of pull the tail one way, next step pulls it the other.
The balance, was that probably for balance and things like that?
Yeah, and it also was really good for those ankylosaurs that you like so much, because if they pull up on their back leg, it helps to swing that tail around and add extra strength. So thinking about, say, Job, with the mention of the behemoth and the tail that sways like a cedar tree, of all the animals in the fossil record, the dinosaurs match this best, in part because of that little spine that comes off of the femur that anchors the muscle, along with those neural spines. That shows us that the tail extends outward, and when they walked, it swayed back and forth.
Oh, that's
fascinating stuff. Right?
Yeah, that's great.
So dinosaurs have all these interesting little bits of anatomy that help tell us these are dinosaurs. The pterosaurs are different. They have a long finger. It's actually the fourth finger. Yeah. It's our ring finger. It's their wing finger.
That's their wing
Do
finger.
You have the wing. I have the wing. And so they've got that, and their legs splay out as well. So they're not dinosaurs. Their legs don't tuck in close. They're stuck kind of out on the side. And again, the Jurassic Park and Jurassic World movies model that pretty well when they have them on the ground.
I've been kind of impressed. They get those.
Jurassic Park 3, that was really
sweet,
good.
Yeah.
Jurassic World, where you got this little pterosaur that's pulling up a triceratops, that
pretty much.
There's some laws of physics that it's not working there. But
maybe a Quetzalcoatlus might have got close, but I don't know.
Even still, think about that. The largest of all the pterosaurs probably still weighing only about 150 pounds.
Yeah, they're pretty light. Well, were the bones solid or hollow?
Their bones were hollow.
That's what I thought.
And so are some of the dinosaur bones as well. It's a feature that they share that the crocodilians don't. So one way that we can say that the pterosaurs and the dinosaurs are a little more similar to each other is by some of that bone structure and a few of the skull structures as well.
And I got about 1 million questions, and I know we're running out of time, but it's like...
Yeah, we don't have a million seconds left.
Yeah, that's a problem. But I know I always think, okay, let me ask you this question. What do you think Leviathan is in Job chapter 41? That's
a really good question. And when I talk to my students about this, I tell them that actually I don't think that there's enough anatomical detail in Job to help us make a strong argument on this. We know that it's an aquatic animal, it's got scales, it's powerful, it's fearsome, and so what could that be? In the fossil record, quite a lot of things.
I know. I've had the debates between the Kronosaurus and the Hadrosauria, because it could go in the water, but they had these weird chambers, and you could a chemical mix inside, and all kinds of weird speculations, which are fun, but we really can't get there from here, it looks like. So I'm just curious.
We couldn't even rule out, I would say, some of the big crocodiles that are in the fossil record, because when you think of a lizard with great armor, that one comes to mind.
Oh yes, absolutely, you're right. Yeah. So. Well, we got to wrap it up.
Oh,
Marcus, this was fun. This was a whirlwind, man.
Thank you so much.
Thank you for coming on the show. I appreciate it. Thank you for joining us on the Revolution Against Evolution, and we will see you next time.